some macros here that were just turned in to me. A student in CS530 used macros to solve a problem. So many of you had 237 with me. And I gave him this problem. That is, there's a polynomial equation that I want you to solve given values. So you've got, ax cubed plus 2by squared kind of thing. And I've given the values for a, b, c, d, and so on. And their job is to solve this in the fewest number of instructions possible. So I've done this in a variety of different ways over the years. I've changed the equations a little so people can't just recycle the code. And I had a student this time come to me and say, Mr. Riggins, I was reading ahead. So if my program has macros in it, do those count? Because their goal was to write it in as few lines of code as possible. So his idea was, wait, can I use macros to take instructions out of here? Have a macro call to stand for 8 or 10 lines of code. So if you have ax cubed y squared, the student says, can I replace that term with a macro call that doesn't count for the number of lines I used? And I said, sure, that's brilliant. Why didn't I think of it? So, okay, he did that. So he wrote the macros. So he won the prize here for the shortest program. But the point here is his program was correct and functions correctly. And it turns out to be a great little example of macros that I didn't write and contrive. And they have the benefit of being fairly short. So I want to look at how this works with the macro expansion, and one in particular I want to talk about is the process that you guys are going to go through to do the first pass here, which is save the macro definitions that you can then turn around and use. Okay, so the names for these aren't the best in the world, but I'm going to use them. Multi-5 macro. Move \1 d0 mul \2 d0 multiply \3 d0 multiply \4 d0 multiply \5 d0 move dot L d0 /6 end in. All right, so this is a macro definition. So when you encounter this, what are you going to do? What do you need to store? What do you think? Now he has 1, 2, 3, 4, 5 macros that he has written, and then more are called. So there may be as many as 15 macro invocations in this program. So, okay, we'll just deal with this one right here. What do we need to do? So you're going along with your file parser. How do you know when you found one?
Macro.
Macro what? How do you know if you found a macro definition?
Macro opcode.
If the opcode is equal to macro. Yes. If the opcode is equal to macro, then it's a macro definition. Okay, now you're going to have to remove this code from the source. Okay, so you're going to take it out. So you're going to go somewhere else and start and keep going till you find what? An opcode equal to
And
M. Exactly. So when you go, what are you going to do? I mean, you already have your code. You're doing line by line by line by line. And there aren't any macro invocations or definitions, rather, in what you've done so far. So we assume it all works just fine. Now we've got a monkey wrench thrown into the works. You have to do something different. Well, you don't have to change what you have. What you have is fine. But when you hit an opcode that's equal to macro, then what?
You're going to have to comment it out and replace it with the stuff that's in the macro definition?
You're not actually going to comment it out. You're going to remove it. You're going to remove it. You don't want to see the macro definitions in the listing file. They don't need to be there. So, okay, the next pass, your third program will be the expansion phase. But you need to be able to do that. Okay, so let's talk about what happens with the expansion. So what is that going to look like? Well, let's see here. That was multi-5. So I have the expanded file. By the way, you can run the actual macro processor installed on Edoras and see if you're getting the same result. You can do that. The directions in the class website for how to do that. So if you run it, what you're going to get is, my goodness, okay. What you're going to get is a .se file that has the macro expansions in them. You want to look at that to check and see that it's worked correctly. Okay, this is called as follows. So later on, so the expansion, that's not part of the program. These could in fact be in a separate file. But traditionally, historically, they go at the beginning before your actual code starts. All right, so this definition sits before the start label, before the program begins. And the call looks like this. So of course, in the expansion phase, you commented it out. And we have multi-5, $2, B, Y, 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 B2. Now B and Y are labels in the program that have values, 2, 6, whatever they might be. Okay, can you guys see this all right? So, what does this get expanded to? All right, the expansions. We're going to go right down the line. Move.w, move.w, \1, D0. Okay, it's direct literal substitution, which means this first symbol is $2. It replaces \1. Okay, the next one. MULS. So we have 2, 3, 4, 5 here, all with MULS. So 2 is B. D0. MULS. Y. D0. MULS. Y. D0. So we've got 1, 2, 3, 4, and I need 5. MULS. Y. D0, move dot L, D0, D2, I'm sorry, this is So this is what you have to do. Well, again, it's exact substitution. If there's a \6, this is 1, 2, 3, 4, 5, 6. So you're not looking at it, you're not analyzing it, you're not trying to figure out if it's okay. It's just if there's a \6, you put the 0. If there's a \1, you put #2. Clear as mud? Okay. Yes?
What's the function, what's the macro called? What's the name of the macro?
It's called multi-5. They're not the best names in the world, but he made them up, so I kept them. He did multi-3, 4, 5. So he picked groups of terms and made macros out of them. Someone else asked me, can I do subroutines? I said, well, no. No, because that would be silly to jump out and do AX cubed. But a macro, it's not silly because it's right there. Yeah.
So this we only have to do for program 3. Program 2, we're just deleting the line that says.
That's right. This part, the expansion, is more complex. So that's going to be program 3. Program 2, what you have to do is remove this from the source code. The macro call is going to be in there, and you're not doing anything with it. You're just going right through. So only thing you're going to touch is what starts with macro and ends with end-in. Yes.
Remove and store it, right?
Yes.
Okay.
So my question for you guys, someone else had a question. What are you going to store and how, and what data structure in what way? Okay, do we still need labels, opcodes, operands? Yes, we do. We do. And for this expansion phase, frankly, I'd just as soon you threw away the comments. They're not useful for anything. So the comments that the writer used when he was writing the macro, well, I have lived to regret documenting things so thoroughly because all of my students have the same comments in every single program that are inserted by the macro expansion. So you can leave the comments behind. I think it's probably better. They're in the original, which is where they need to be. But don't carry them forward and stick them in every place every time you do this macro expansion. There's no reason to do that. All right. So what information do we need? Well, the obvious here. We need the name of the macro. Okay. So how do you tie that to the set of instructions that goes with it? You understand we have a set of these. Okay, so we have like line in, line out, convert from two's complement to ASCII, and so on. We have these standard macros. There is set EVT for error handling. There's init IO, set up the input output. Right, there's a bunch of these. So how do I get the instructions that go with line out? Yes?
Keys and values?
Well, keys and values perhaps, but it's not one key, one value. Well, it's one key, but is it one value? So how do you have that name mapped to the set of instructions?
Can we create an object that has all of this, like all the instructions?
Well, I want you to think about it. Now, there are different approaches that can be taken, but let me ask you this. Let me ask you this. Would it work? Okay, how would you store this? As one thing. Well, how'd you store the file you read in? I mean, it's the same thing, isn't it? Okay, so maybe you have a vector of structs, you know, maybe whatever you call it. Okay, could that vector hold 5 lines, 10 lines, 13 lines? And those lines could be label, opcode, operand, forget the comments. Work? Could that be a value in a map? Can I have a key value pair where the key is line out macro and the value is a complex data structure, a vector of structs? Would that work? Of course it would, yes it would. Okay, that doesn't seem so hideous, does it? You ask for line out and you get a vector with all of those lines right there, good to go. Is that easy peasy? Well, it's not falling off a log easy, but it makes sense, doesn't it? Okay, what else? What are you going to do with the parameters? Maybe do we need a lookup for the parameters? How hard would it be if I see a backslash, take that and look it up and write the value there? Would that be easy? That wouldn't be terrible, would it? So we might have a def tab, and the book doesn't have these structures in it, the text, because it was written before modern object-oriented languages were used for this stuff. It actually existed, but back then we were using Pascal. Does anybody even know what that is? It's a dead language. I seem to be an expert in dead languages, yes. It's a dead language, but in Pascal you couldn't easily do this. You can with C++ using the standard template library, use a map. It's super easy. So you make a map. Okay, so you've got def tab, which is going to hold all of your macro definitions. The key is the name of the macro, and the value is a vector, and however you stored this, maybe you have a vector of vectors, maybe you have a vector of array. There are different ways it could be done. I mean, you guys took different approaches. Okay, what about the parameters?
Another map?
What's that?
Would it be another map?
I don't know that you actually need a map to look up 10 things. But you could. But you have to know which map. So if you do a map with the parameters, then what are the keys and the values? And if the key is \1 and the value is what it replaces, the parameter, how do you distinguish between the different macros? So you need all of them. You need all of them. So one approach might be a parameter table. Okay, the lookup works. Then what are the keys and values? What are the keys and values? Well, it helps that these go in order, right? They're in order. You don't ever have to do anything different that way. Therefore, the key could be the name of the macro, and the values could be a vector of the parameters. Could it be? Think about it. This is not the only approach. So, okay, we've got the lines of the macros, we've got the \, the parameters. Now, one of the issues that we don't see here is where we have labels. inside a macro. If we have loops or branches inside a macro, which we very well may have, then you have to handle the \at problem. The \at. So the way this works is, suppose I have next. And in the macro, I would write next \at. It's terrible writing. Next \at. Then in the expansion phase, I would say next 0 for the first macro invocation. Next 1. Next 2. Next 3, and so on for each invocation. Because without this, I can only call a macro once in a program. If I called it more than once, then how many nexts would I have? I have 2 nexts. And I'm branching to next. Well, which branch do you want? Which next? So each label must be distinct, which means if we're doing macro expansion with a label in it, those labels can't have the same name. Can't be. Does everybody follow me? Okay. So we have to come up with a way to store that information. I actually have a handout here. I decided that it was more complicated than I wanted to try to do in class, so I used the students instead. But this has labels in it. This is a macro definition here. This is one I wrote, and it removes leading zeros from numbers. That's the purpose of this one. It's called strip, and it removes leading zeros. So you can see all of the labels have the \at on them. So it gets replaced with a new number, because if you have to print more than one number in your program, then we have a problem. So you guys pass this down. Okay. So how do we handle that situation where we have duplicate labels? We do that by appending the number to it. Next 0, next 1, next 2, and so on. So how do you do that? Yeah, thanks. How can we manage that situation? Anyone? The \at does it, right? But how are we going to store it? You might say, okay, a counter, that's easy. But the question is, how do we know which counter goes with which macro? Which counter with which macro? So, okay, question. Could we use a map again? Could I do a count tab? Line out, 1, strip, 3. Okay, just got an integer in it. Can I do that? Sure. That way I can keep track of the invocations, and that number has to be appended to the labels here. There aren't any on the board. So looking at this, I think you can see you've got loop mcr \at. Questions? Okay. So does this seem like the program from hell? Not so much, I don't think. You did the hard part, the parsing. Now I'll tell you what I'm concerned about. I saw some of your code. It was like, oh heavens. Don't anybody touch it. But now you have to touch it. If you're going to parse lines, you got to have the backslashes in there, and the \at, and the \numbers. You have to allow for them. Okay, so you may not be able to use the same code as is to parse the lines here. If you start seeing gremlins, you may need to rework that. It's important that you be able to parse these things correctly. So I have posted another set of code on the board or on the class website for you guys to use. I will post more samples as we go forward. But what I want to warn you about, the worst case scenario here, is that we get to the end of the semester, you're working on your last project and your file parser fails. Oh my, would that be hideous. Now I want to also add something. That macro preprocessor that's installed on Edoris that we've been using for quite some time now was written by a student in CS530. It was actually written in 1999 by a guy named Brian Fox. It's written in Java. It's not C++. So I know that Java is a little harder with C++ than it would be with Java. However, this was a class project in 530, and that macro preprocessor he wrote is bulletproof. I added floating point instructions a couple of years ago, I think maybe in the summer of 2012. It's an interesting problem. This CPU only supports integer instructions, so how do you do floating point arithmetic on a machine that doesn't have the ability? Well, you have to actually simulate that. One of the most interesting of these was the power function. Right, there is a standard method, the IEEE format, for storing floating point numbers. But how do you calculate that using integer instructions? It's an interesting problem, and the overflow, of course, as it exists, causes issues, but how do you do it? Yes?
Can you parse it and break it up?
Well, I mean, you can multiply by, 1,000 or whatever and pretend they're integers, but that doesn't work. Plus, there's no power function.
Is it the modular?
This is actually, actually, I'm pretty proud of this work. That is calculated using square roots. Any of you have numerical analysis in this class? Did you ever take that class? I try to steer all my students away from that's hard math, 541. But yeah, this is a numerical method. But how would you use square roots? Anybody know? Well, okay, you have a floating point number. So what's x to the 1/2? The square root of x? Okay, so that's the square root of x. What about this? The square root of the square root of x. So this is x to the 0.5, x to the 0.25. So if you keep going and do it where you have a bit and skip it where you don't have a bit, all of that added together will get you close to that. Now that was messy programming. And in assembler, they were macros. So that was, I was proud of that. That was messy work. Anyway, the only problem with that is it's slow. It's slow. First you calculate the square root using Newton's method. That's not fast. Then you have the square root, you take the square root of the square root, and then the square root of the square root of the square root. You keep going for 17 to 18 bits. And the precision is there and it actually works, but it's slower than snot. But anyway, the point I want to make is, I wrote these macros, I think in the summer of maybe 2012 or 2013, and I ran them through the preprocessor and it worked. It actually turned them into code, and the students have been using it in the course. So that code was written in 530. So I'm not going to ask you to implement all of the features that are in that particular code because he had some help. It was written in Java, and Professor Vinci gave them some chunks. And I'm not giving you chunks, I'm making you do it. So we're not actually having the same endpoint here. But the point is, this is not an unreasonable project to ask you to do. So I know some of you have been reticent, there's been some kind of, oh gosh, this is awful, I don't want to do it. But if you want to get through the class with a good grade, guess what, you have to. Now I want you guys to trust me, I know some of you are concerned about your grades. The performance on the exam wasn't great, maybe the programs didn't work out of the gate. Okay, well show me something and you can have the grade. This is an upper division course and my expectation is that you guys are not C students. Those guys, they changed majors last year, the year before. So I think you guys are the winners, and you have to show me something, I'll give you the grade. Having said that, I see a lot of empty chairs here. So, okay, the percentages can apply to the people that can't be bothered coming to class. There's only 40 of you, I have eyes in my head, I can see who isn't coming to class and who is. So you might mention to your teammates that it would be a good idea to start coming to class, unless they want to take this again. At any rate, so I would like to see your teams dive in and make some progress on this. Use the things we've talked about today to strategize and see how you want to make this thing work.